Hello and welcome to Kubernetes Architecture from Simplilearn. We're going to take a deep dive into the Kubernetes architecture. If you're new to Kubernetes, we already have an introduction that goes and provides an overview of Kubernetes, and we have the link below so you can go straight to that if you want to have a refresher. Otherwise, hang around and join us in this presentation. And if you want to see more of these videos, hit the subscribe button, and if you want to get notified, hit the notification bell, and every time we post up a new video, you'll get the notification right onto your phone or on your desktop that the new video has been uploaded. And as always, if you have any questions, please post them in the comments below. We do read the questions and we try to respond to all of them as quickly as we can. With that said, let's jump into Kubernetes architecture. So we're going to break out the presentation into the following areas. We're going to cover what Kubernetes is and why you want to be using it. We're going to introduce the actual architecture and provide an overview of how it contains the containers and the other components that you'd have within the architecture. We'll also compare Kubernetes with Docker Swarm, and one of the things that you hear with Kubernetes almost in the same breath is Docker. We have to be careful not to confuse Docker from a container point of view and Docker Swarm, which is a container management tool. And Kubernetes is also a container management tool, so we'll compare the two of those. And then we'll look at the hardware and software components, and then finally do a deep dive into the architecture of Kubernetes and provide a case study of where Kubernetes has been used successfully in the past. So let's jump into this. So what actually is Kubernetes? So Kubernetes is a tool that was designed to actually help manage and contain large groups of containers. It was developed originally by Google out of the Google Borg solution, and then open sourced by Google. The actual environment allows you to manage large groups of containers. So if you're a developer in DevOps and you're working with Docker, then you're used to the concept of a container. And you'll also know that containers and cloud technologies tend to be almost breathed in the same breath. So the work that you're doing with Kubernetes is to be able to manage large groups of containers inside of the cloud. The thing that's great about working with Kubernetes is that it is incredibly flexible and it allows you to have incredibly complex applications run efficiently. So let's step into why you'd want to use Kubernetes. So a couple of key points. Kubernetes itself is an open source solution originally developed by Google, but it is available on most cloud platforms today. So AWS, Google Cloud, Microsoft Azure, all of them support Kubernetes. And what you'll find is as you're setting up your infrastructure, particularly if you're using containers, you'll see that the support for Kubernetes is floated up very, very efficiently and effectively by all three vendors. It's extremely useful for being able to manage large modular environments, and that's really kind of the, I think one of the big benefits of Kubernetes is its modularity, is that it really breaks down containers into their smaller parts. And once you do that, it becomes much more efficient for you as an administrator to be able to manage that entire environment. The reproducibility of Kubernetes is extremely high. You can build out infrastructures very quickly and have them being able to manage and have containers coming on and off and killed and created to be able to help load balance your entire environment. And so again, we keep talking about containers, but that's really what Kubernetes is all about, is being able to manage your applications that are managed through containers and being able to do that in a virtualized infrastructure. And the thing that's also really good with Kubernetes is it's really easy to deploy solutions. You just have to use a simple curl call and you can actually push out your Kubernetes infrastructure. So let's have an overview of the Kubernetes architecture. So Kubernetes is really broken up into three key areas. You have your workstation where you develop your commands and you push out those commands to your master, and the master is comprised of four key areas which essentially control all of your nodes, and the node contains multiple pods, and each pod has your Docker container built into it. So consider that you could have a really almost an infinite number of infinite number of nodes being managed by the master environment. So you have your cluster, which is a collection of servers that maintain the availability and the compute power, such as RAM, CPU, and disk utilization. You have the master, which is really components that control and schedule the activities of your network. And then you have the node, which actually hosts the actual Docker virtual machine itself and be able to actually control and communicate back to the master the health of that pod. And we'll get into more detail on the architecture later in the presentation. So you keep hearing me talk about containers, but they really are the center of the work that you're doing with Kubernetes. And the concept around Kubernetes and containers is really just a natural evolution of where we've been with internet and digital technologies over the last 10, 15 years. So before Kubernetes, you had tools where you're either running virtual machines or you're running data centers that had to maintain and manage and notify you of any interruptions in your network. Kubernetes is the tool that actually comes in and helps address those interruptions and manages them for you. So the solution to this is the use of containers. So you can think of containers as that natural evolution from 15, 20 years ago. You would have written your code and posted it to a data center. More recently, you probably posted your code to a virtual machine and then moved the virtual machine. Now you actually just work directly into a container, and everything is self-contained and can be pushed out to your environment. The thing that's great about containers, they're isolated environments, very easy for developers to work in them, but it's also really easy for operations teams to be able to move a container into production. So let's kind of step back and look at a competing product to Kubernetes, which is Docker Swarm. Now, one of the things that we have to remember is that Docker containers, which are extremely popular, are built by the company Docker and made open source. And Docker actually has other products. One of those other products is Docker Swarm. And Docker Swarm is a tool that allows you to be able to manage multiple containers. So if we look at some of the benefits of using Docker Swarm versus Kubernetes, one of the things that you'll find is that both tools have strengths and weaknesses. But it's really good that they're both out there because it helps it really kind of justifies the importance of having these kind of tools. So Kubernetes was designed originally from the ground up to be auto-scaling, whereas Docker Swarm isn't. The load balancing is automatic on Docker Swarm, whereas with Kubernetes you have to manually configure load balancing across your nodes. The installation for Docker Swarm is really fast and easy. I mean, you can be up and running within minutes. Kubernetes takes a little bit more time, is a little bit more complicated. Eventually, you'll get there. I mean, it's not like it's going to take you days and weeks, but it is a tool that's, when you compare the two, Docker Swarm is much easier to get up and running. Now, what's interesting is that Kubernetes is incredibly scalable, and that's its real strength, is its ability to have strong clusters. Whereas with Docker Swarm, its cluster strength isn't as strong when compared to Kubernetes. Now, you compare it to anything else on the market, it's really good. So this is kind of a splitting hairs kind of comparison, but Kubernetes really does have the advantage here if you're looking at the two compared to each other for scalability. I mean, Kubernetes was designed by Google to scale up and support Google Cloud network infrastructure. They both allow you to be able to share storage volumes. With Docker, you can actually do it with any container that is managed by the Docker Swarm, whereas with Kubernetes, it manages the storage with the pod, and a pod can have multiple containers within it, but you can't take it down to the level of the container. Interestingly, Kubernetes does have a graphical user interface for being able to control and manage the environment. The reality, however, is that you're likely to be using terminal to actually make the controls and commands to control your either Docker Swarm or Kubernetes environment. It's great that it has a GUI to get you started, but once you're up and running, you're going to be using terminal window for those fast, quick administrative controls that you need to make. So let's look at the hardware components for Kubernetes. So what's interesting is that Kubernetes is extremely light. Of all the systems that we're looking at, it's extremely lightweight. It allows you to have, if you compare it to like a virtual machine, which is very heavy, Kubernetes is extremely lightweight and hardly uses any resources at all. Interesting enough, though, is that if you are looking at the usage of CPU, it's better to actually take it for the cluster as a whole rather than individual individual nodes because the nodes will actually combine together to give you that whole compute power. Again, this is why Kubernetes works really well in the cloud, where you can do that kind of activity rather than if you're running in your own data center. So you can have persistent volumes such as a local SSD, or you can actually attach to a cloud data storage. Again, Kubernetes is really designed for the cloud. I would encourage you to use cloud storage wherever possible rather than relying on physical storage. The reason being is that if you connect to cloud storage and you need to flex your storage, the cloud will do that for you. I mean, that's just an inherent part of why you'd have cloud storage. Whereas if you're connecting to physical storage, you're always restricted to the limitations of the physical hardware. So let's kind of pivot and look at the software components as compared to the hardware components. So the main part of the components is the actual container, and all of the software running in the container runs on Linux. So if you have Docker installed as a developer on your machine, it's actually running inside of Linux. That's what makes it so lightweight. And really, one of the things that you'll find is that most data centers and cloud providers now are running predominantly on Linux. Inside of the container itself is then managed inside of a pod, and a pod is really just a group of containers bundled together. And the Kubernetes scheduler and proxy server will then actually manage how the pods are actually pushed out into your Kubernetes environment. The pods themselves can actually then share resources for both networking and storage. So pods aren't pushed out manually. They're actually managed through a layer of abstraction part of their deployment. And this is the strength of Kubernetes. You define your infrastructure, and then Kubernetes will then manage it for you. And there isn't that problem of manual management of pods if you have to manage the deployment of them. That's simply taken away, and it's completely automated. And the final area of software services is on Ingress, and this is really the secure way of being able to have communication from outside of the cluster and passing of information into that cluster. And again, this is done securely through SSL layers, and allows you to ensure that security is at the center of the work that you have within your Kubernetes environment. So let's dive now into the actual architecture before we start looking at a use case of how Kubernetes is being employed. So Kubernetes, again, is we looked at this diagram at the beginning of the presentation, and there are really three key areas. There's the workstation where you develop your commands, and then you have your master environment, which controls the scheduling, the communication, and the actual commands that you have created, and pushes those out and manages the health of your entire node network. And each node has various pods. So we break this down. So the master node is the most vital component. With the master, you have four key controls. You have etc., controller manager, scheduler, and API server. The cluster store, etc., this actually manages the details and values that you've developed on your local workstation, and then we'll work with the control, schedule, and API server to communicate that out, those instructions of how your infrastructure should look like to your entire network. The control manager is really an API server, and again, this is all about security. So we use RESTful APIs, which can be packaged in SSL to communicate back and forth across your pods and the master, and indeed the services within each of them as well. So at every single layer of abstraction, the communication is secure. The scheduler, as the name would imply, really schedules when tasks get sent out to the actual nodes themselves. The nodes themselves are dumb nodes. They just have the applications running on them. The master is really doing all of the work to make sure that your entire network is running efficiently. And then you have the API server, which has your REST commands and the communication back and forth across your network that is secure and efficient. So your node environment is where all the work that you do with your containers gets pushed out to. So a work is really it's a combination of containers, and each container will then logically run together on that node. So you'd have a collection of containers on a node that all make logical sense to have together. Within each node, you have Docker, and this is your isolated environment for running your container. You have your kubelet, which is a service for conveying information back and forth to the service about the actual health of the Kubernetes node itself. And then finally you have the proxy server, and the proxy server is able to manage the nodes, the volumes, the creation of new containers, and actually helps pass the health of the container back up to the master to see whether or not the container should be either killed, stop started, or updated. So finally, let's see where Kubernetes is being used by other companies. So, Kubernetes is being used by a lot of companies, and they're really using it to help manage complex existing systems so that they can have greater performance, and with the end goal of being able to delight the customer and increase value to the customer, and hence increase value and revenue into the organization. So an example of this is a company called BlackRock, where they actually went through the process of implementing Kubernetes. So BlackRock had a challenge where they needed to be able to have much more dynamic access to their resources. They were running complex installations on people's desktops, and it was just really, really difficult to be able to manage their entire infrastructure. So they actually then pivoted to using Kubernetes, and this allowed them to be able to be much more scalable and expansive in the management of their infrastructure. And as you can imagine, Kubernetes was then hooked into their entire existing system and has really become a key part of the success that BlackRock is now experiencing of a very stable infrastructure. And the bottom line is that BlackRock is now able to have confidence in their infrastructure and be able to give that confidence as back to their customers through the implementation and more rapid deployment of additional features and services. So that's our presentation. I hope you got good information about the architecture of Kubernetes out of that. Again, if you like this presentation, hit the subscribe button, and if you hit the bell button, you'll be notified when new videos are dropped. If you have any questions, please post them in the comments. We have additional training as well at Simplilearn, where you can find out more information about Kubernetes and actually dig deeper into Kubernetes and how it applies to the work that you yourself may be doing today.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.